Hello, welcome back. So, presumably at this point, many of you have already walked through the detailed proof of this proposition, the detailed and rigorous proof of this proposition on the next page, and maybe even have taken the ideas and written them in your own words now. Either way, let's talk through it. So, let's prove the following. Let A and B be numbers. Let A sub n and B sub n be sequences. Suppose that A sub n converges to A and B sub n converges to B. Then the claim is that A sub n times B sub n converges to A times B. And on this page, what happened in the presumably preceding video is we talked through a false proof and then got the ideas to turn that false proof into a correct proof. So let's write this correct proof. All right, well, let's do it. So, if we're going to find a correct proof, we should start by stating the assumptions. Let's let A and B be numbers. Let A sub n and B sub n be sequences. Suppose A sub n converges to B and B sub n converges to B. We must show that A sub n times B sub n converges to A times B. Cool, so what does that mean? That means we need to show that for every epsilon bigger than 0, there exists some big N, such that for every little n bigger than big N, the absolute value of the difference between A sub n times B sub n and A times B is less than epsilon. So, with that in mind, how is this going to go? Well, we need to prove something is true for every epsilon bigger than 0. So let's consider any epsilon bigger than 0. Well, now we need to come up with a choice of big N. So we're going to come up with some different choices of big N. So what do we know that we will need based on the previous page? Because that's how we'll choose our big N. So since A sub n converges to A, there exists some n sub A, such that for all little n bigger than big N sub A, at this point, presumably, everyone has attended enough of my lectures to know that these documents will invariably be riddled with typos. That should be an A. Absolute value of A sub n minus A is less than anything we want, but in particular we know what we want. We want epsilon divided by the absolute value of A plus the absolute value of B plus 1. Similarly, since B sub n converges to B, there exists some nb, so that for all little n bigger than big N sub B, absolute value of B sub n minus B is less than two different things. And those two different things, well, we know that we wanted B sub n minus B to be less than 1 in absolute value, and also B sub n minus B to be less than epsilon divided by absolute A plus absolute B plus 1. And whenever you see two different choices of big N, chances are you want to take the max, because I want to guarantee that little n is bigger than this and little n is bigger than that, so I can use both of these implications. So let's let big N be the max between big N sub A and big N sub B. All right, so remember how a proof of limit should go. We need to consider any epsilon bigger than 0, then come up with a choice of big N. Done. We now need to consider any little n bigger than big N, and then show that the difference between the sequence we want to analyze and the limit that we think it has is less than epsilon. So let's do it. Let's consider any little n bigger than big N. Well, since little n is bigger than big N is bigger than or equal to big N sub A, this difference is less than epsilon divided by absolute A plus absolute B plus 1 by that line. Since little n is bigger than big N is bigger than big N sub B, we know that Bn minus B is less than 1 in absolute value because of that, and is less than epsilon divided by absolute A plus absolute B plus 1. Well, we've already considered any little n bigger than big N. I don't need this line. First, let's use the fact that since little n is bigger than big N sub B, B sub n minus B is less than 1. As a consequence, well, this should look really familiar. Absolute value of B sub n, well, that's the same thing as absolute value of B sub n minus B plus B is less than or equal to absolute value of B sub n minus B. Hey, look, there's that. Plus absolute value of B, that's less than 1, plus absolute value of B. So here's an important fact that we'll reference later on. We now know that absolute value of B sub n is less than 1 plus the absolute value of B. And somehow, like, the rest of this should be like autopilot because you've already done it. But let's go through these motions. So, absolute value of a sub n times b sub n minus a times b, that's the same thing as absolute value of a sub n times b sub n minus, and now if I do a times b sub n or b times a sub n, I'll get slightly different analysis for which I'll need a different assumption than this. So let's just do a times b sub n. Let's subtract a times b sub n and add a times b sub n, just as on the previous page, minus a times b, by subtracting and adding a times b sub n. So sometimes it's nice to have like many lines of manipulations of equations with what's going on in each step in a proof. By the triangle inequality and doing a little bit of factoring, we know that that's less than or equal to a sub n minus a times absolute b sub n plus absolute a times b sub n minus b. But b sub n, we know that that's less than or equal to absolute value of b plus 1 by the stuff above. So this is now less than absolute value of a sub n minus a times b sub n plus 1 plus absolute value of a times the absolute value of b sub n minus 1, b sub n minus b. So again, I'm running into this problem where I've given myself just not quite enough space. Well, now we have bounds on a sub n minus a and b sub n minus b. We know that a sub n minus a is less than epsilon divided by absolute a plus absolute b plus 1. B sub n minus b is also less than epsilon over absolute a plus absolute b plus 1. So that means this whole thing, well, this bit is less than, the whole point is to get rid of that n. I can now replace both of those with epsilon divided by a times a plus b plus 1 and get a result that is strictly bigger. Right? I'm making these quantities bigger, so the whole result will get bigger. Cool. So what does this turn into? Epsilon divided by absolute a plus absolute b plus 1. So if you like, this manipulation is occurring on both of these. I'm going to turn them both into this. And I'm going to simplify some also. I know it says to do this in the next step, but I don't have enough space. Absolute b plus absolute a plus 1 by combining these terms. And so by doing a little bit of, not simplifying now, I suppose instead I'm canceling, you see that this is equal to epsilon. So let's just see if we've actually done what we need to do. We started by considering any epsilon bigger than 0. Good. So we've proven something for every epsilon bigger than 0. We then came up with a choice of big N. Let big N be the max between n sub a and n sub b. So there exists some big N. We considered any little n bigger than big N, so that means we've proven something about every little n bigger than big N. And what did we prove? We proved that a sub n times b sub n minus a times b is less than epsilon. That's exactly the definition of the limit. So that completes the proof. All right, so hopefully this has been useful. Hopefully I wasn't talking into the air for no reason. And in particular, hopefully these ideas are somewhat useful in thinking about the limit law for the quotient and division rules that I'm having you do for homework. So I'm going to go ahead and stop there. This is still during the summer, so I look forward to seeing you once the semester begins, though that doesn't make any sense in context. All right, talk to you later.